Alright, we're taking a look at section 4.1. Our learning goal here is that we want to be able to identify polynomial functions. So first of all, we might just be given an equation and they're going to ask us whether or not it's a polynomial function. The other thing is we want to be able to graph polynomial functions. We want to understand the end behavior, and then we're also going to look at some tables of values. So a polynomial is just a monomial or a sum of monomials. Poly just means more than one, so polynomial function just means we're going to have, one or more terms. Remember that we always want to write these in descending order, so the highest exponent goes first. And also, in order to have a polynomial function, the exponents must be whole numbers, and the coefficients must be real numbers. The end behavior. We have all these things that can happen at the end. There's actually only 4 possibilities. The function, as we go down to the left, can either be ending like that or it can end like that. As we go down to the right, the function can go up or it can go down. So we're going to be looking at what happens as x approaches positive and negative infinity. Remember, negative infinity is this way, positive infinity is this way, just telling us the direction. The degree of a polynomial is that highest exponent. Alright, so looking at end behavior. First of all, remember, f of x just means y. If I have an odd degree, and if that leading coefficient is positive, here's what the end behavior looks like. It goes down at this end, up at this end. The way we describe it is y is going to negative infinity as x is going to negative infinity. This means y is going to positive infinity as x is going to positive infinity. Let me show you a couple of these. Give me a number that's odd. Sarah, give me a number that's odd. Okay. So if I go to y equals and I put in x cubed, I'm going to graph it. Here's what x cubed looks like. Can you see that as x goes to negative infinity, y is going to negative infinity? Same thing here. Let's change it. Let's make it another odd number. Let's make it 7. And it's going to look very similar. See how it still has that same behavior. As long as that degree is odd and that leading coefficient is positive, this is the way the end behavior is going to go. It goes down, up. That's what we call that kind of behavior. Now, what if I put a negative in front? What's that going to do? If I put a negative in front of here, what does it do? Flips it over x-axis. Flips it over the x-axis. So look at how this is going to look now. I'll use a different odd number, 5. Here's how it looks. The end behavior. As x goes to negative infinity, see this? As x goes to negative infinity, y is going to infinity. As x goes to positive infinity, y is going to negative infinity. This is how we can just show it quickly. Alright, what if we have an even degree? What's our most common even power we use? X squared. We all know x squared is just this parabola right here. And do you see that? If I have y equals x squared, the end behavior is this. As, f of x goes to infinity as x goes to negative infinity. Alright, does that make sense? And then what if I put a negative in front of here? What's it going to do? Reflect it over, not y, x-axis. I'll change this to a 4. And look what happens. Y is going to negative infinity as x is going to negative infinity. Y is going to negative infinity as x is going to positive infinity. So that's this situation. Alright, we already did this. Test out functions with odd and even degrees. Let's do just one more. Let's make it a little more complicated function. Let's do like x raised to the 4th plus 2x minus 3. Alright, so what do you guys think is the end behavior? Is it this is hard to do with my fingers. Is it down, down, or is it going to be up, up at the end? Or is it going to go like that or like that? What's it going to be? Up, up? Let's see. Here's the way it looks.
Oh, yeah.
Up, up. You guys are right. Okay? All right. Let's look at the next part. Decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. Okay, so we look at these exponents. Are all the exponents whole numbers? Yep, so this is a polynomial. Standard form means that the highest exponent has to come first. So this is going to be negative 3x to the fourth plus 2x squared plus 6x plus 1. What's the degree? 4. What would be the type then? You know what a 4? Quartic. Quartic. And then it asks for the leading coefficient. Here's the leading coefficient. That leading coefficient is negative 3. What's the end behavior going to be? Is it going to be up, down, up, or down, down?
Down, down.
Down, down is right. Number 2, is this a polynomial function? No, because this would be x to the negative 1. Negative 1 is not a whole number. These are whole numbers, by the way. Whole numbers start with 0. 0, 1, 2, 3. That's a weird 3. 4, ... Okay? So this is not going to be a polynomial. What about this one? Yes or no? Polynomial. Why do you think no, Quinn?
Because it's not a whole number.
Okay, the exponent here is 1. 1's a whole number. Any other reason? Do we think it's going to be 1? So it is going to be 1.
Yes.
A lot of times, though, people get confused about this. They're like, yeah, but can you have a radical 15? I thought it said that they had to be real coefficients. Is radical 15 real? Yeah, that's fine. So this is going to be yes. It's already in standard form. What's the degree? 1. So what's the type? Linear. Linear when that degree is 1. And that lead coefficient is radical 15. So since that degree is odd, this one should go down up at the ends. Alright, what about number 4? Polynomial? Yes or no? Yes, the exponents are fine. We do need to rearrange it though. It has to go in descending order. There's descending order. What's the degree? 2's the degree. What do we call that? Quadratic. And the lead coefficient is going to be negative 2. What's it going to do at the ends? Up, up, down, down, up, down, down, up. Down, down. All right. Next one. Evaluate the function for the given value of x. What is a fast way to evaluate this for when x equals 2? Synthetic. Synthetic is faster than plugging it in. If you want to race, go ahead and plug it in and I'll do it with synthetic and we'll see who wins. Okay, that's it. Negative 18, right? That remainder tells us. So that means that when x is 2, my y value is going to be negative 18. That's what that remainder tells us. That's faster than even plugging it in or putting it into your calculator. Alright, you guys tell me the end behavior here. Look at your leading term. Is that going to be up, up, down, down, up, down, down, up?
It's going to be down, down.
Down, down. Here's the way we need to write that though. It's down, down. But the way you write it is f of x approaches negative infinity as x approaches negative infinity. F of x approaches negative infinity as x approaches positive infinity. So this is saying y is going down as x gets small. Y is going down as x gets large. Alright, look at the next one. What's the degree of the next one? 5. The leading coefficient is positive 3. What's it going to be? Up, down, down, up, 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 down, down.
Down, up.
He's got it. Do you guys agree with down, up?
Yeah.
That's right. So the way that I write that is f of x approaches negative infinity as x approaches negative infinity. F of x approaches positive infinity as x approaches positive infinity. This is saying y goes down as x goes down to negative infinity. Y goes up as x goes to positive infinity. Alright, number 8. Describe the degree and the leading coefficient of the polynomial function using the graph. When they ask us to describe the degree, we don't know exactly what it is, but we should know if the degree is even or odd. What do you guys think? Odd. I think of it like this, guys. Odd is opposite. You see what I mean? Opposite in behavior means I have an odd function. The leading coefficient, with the leading coefficient, all we know is it positive or negative? Negative. Very good. All right. Look at the next one here. Now we're into sketching. Sketch a graph of the polynomial function f if f is increasing when x is less than negative 1 and f is increasing between 0 and 1. F is decreasing when x is in between negative 1 and 0, and f is decreasing if x is greater than 1. Also, f of x, what does f of x mean again?
Y.
So y has to be less than 0 for all real numbers. What does this tell me right here? That I always have to be where? Above or below the x-axis? Below. This function always has to be below the x-axis. So now we're trying to kind of think of how this would look. I like to start here. My function is going up until I get to negative 1. So watch, guys. I'm going to call this negative 1. My function is going up until I get to negative 1, but I can't go higher than the axis. What's happening between negative 1 and 0? Is it going up or down? Between negative 1 and 0, what's it doing? Decreasing, so I have to go down. I don't know how far down, but I have to go down. What about between x being 0 and 1? What's happening? Increasing. And then what about when I get to 1 and I go higher than 1? What's it doing? Decreasing. So it's like an upside down W. Kind of like an M. Okay, now it asks us about the degree and the leading coefficients. What can you tell me about the degree? Even or odd? Even. What can you tell me about the leading coefficient? Positive or negative? Negative. All right, last one here. The number of students S in thousands who graduate in 4 years from a university can be modeled by the function right here. T is the number of years since 2010. Use a graphing calculator to graph the function for the interval from t in between 0 and 5. Describe the behavior of the graph on this interval. Alright, you guys don't need to type it in. I've already got it in here. I did a zoom 6. Here's the way it looks. All I'm seeing is that much of it. Now, how is it telling me? It's telling me that this only works between 0 and 5. So I'm going to set my window to just go from 0 to 5. What else was the problem? Do I need to go higher or lower on the y's? Higher. I might want to go up to 30. Let's see what happens. Okay, there we go. So the function is actually decreasing here and decreasing here. So it's really, on this interval, it's going like this, isn't it? Can you see how it looks like it's high here, but it's going down, and then here it's going down? We're just looking at that short little interval. We can describe it like this, or f of x goes to negative infinity as x goes to, actually I would want to say 0 in this case. I'm saying the function is getting smaller as x goes to 0. I really don't want to say negative infinity because it's only true until 0. Then what could I say? F of x is also going where? Is it going up or down here at 5? Down. So it's going to negative infinity as x gets closer to 5 as well. So that's our description. What is the average rate of change in the number of four-year graduates from 2010 to 2015? Well, 2010 is actually time 0. 2015 is time 5. How can I find those values? Well, actually 0 is easy to find. What's 0 going to be? 23. 5, I don't really want to plug it in. I've got it in my calculator. Where can I find the answer for 5? Table. Go to the table. And 5 is going to be 16.75. Average rate of change equals slope. It's the same thing as slope. So all I'm doing is y sub 2 minus y sub 1, x sub 2 minus x sub 1. I need a calculator. So we're going to do this. Negative 6.25 over 5. If I do negative 6.25 divided by 5, I get this. How can I have the calculator change this into a lowest term fraction for me? Math frac. Negative 5/4. That's the average rate of change. So that's going to mean that they're losing 1.25 thousand on average per year. Now that's just on average. That's the average rate of change. Now, what about this last question? Do you think this model can be used before year 2010 or after year 2015, and explain? What would be the end behavior of this if it's a cubic and it's negative? What's it going to be, the end behavior? Way up and way down. Do you think after 2015 it's going to go to negative infinity? No, I don't think it will ever be a time where we have negative infinity students graduating from college. And even before, we wouldn't have infinitely many students. So no, can't be positive and negative infinity for the number of students. All right, any questions?